All right, in this video here, so this is going to be our final video on just solving equations. This is called part 3. And of course, make sure you put your date in as well. And I'm basically just going to recap and kind of summarize the steps for solving equations. So in the first video, we went through the main rules there with those two equality properties that we could use. In the second video, we kind of went through some more examples, going from some easier ones to more challenging ones. And then in this video, we're going to kind of put it all together and just go through again some more of the challenging examples here. So first thing I want to go through are our general rules for solving equations, or we'll call it steps. All right, so your first thing you want to do here is you want to look at each side of the equation and you want to simplify it as much as you possible. So this is where a lot of the work is going to come in. So things that we're going to do are, clear out parentheses using that distributive property. Now, I'm going to put this step in. We're not going to see it today, but we're going to see it in later sections, is we can also clear out fractions and decimals. So for basic fraction problems that we've seen so far, we just have one fraction. It's not really a big deal. It's easy to work with. But as we get to later chapters in this book, we may have more complicated examples that have lots of fractions or lots of decimals. So I will show you techniques later on how to clear out fractions and decimals as well. And then you're also going to combine like terms, right? So the main thing for us is going to be right now to clear up parentheses and combine like terms. So you want to look at each side of the equation and really make sure it is simplified as much as possible. The second thing you're going to do is you're going to get all of your like terms together. On the same side of the equation. So for instance, bring all variable terms to one side and all constant terms to the other side. Now, this is when you're going to be adding or subtracting on both sides of the equation, and you're going to be using the opposites to cancel out. So this is when we're going to try to move things from one side to the other. So if it's like a +4, you're going to use a -4 on both sides, right? So this is the point where you're moving things around. You're rearranging, okay? So sort of rearranging the terms. Once you've done that, then what you're going to do next is you're going to divide by the number with the variable on both sides. So after step 2, you should have just one thing equals one thing. There should be no more plus and minuses. Everything should be cleaned up. So step 3, you're just going to divide by the number with the variable on both sides. And this is that multiplication property there that we learned about. And then step 4 is you can always check your answer in the original equation to make sure you get a true statement, right? If you don't get a true statement, then something is wrong. Either you made a mistake in your check, so make sure you check your check. I have students who do everything right and then they make a silly mistake when they're actually checking their answer and think everything is wrong. So make sure you check your check first, that you didn't make a mistake. And if it still is coming out false, then go back and check all your work because you made a mistake somewhere. If you get an answer, then it should plug in and be true. The nice thing with equations is that you can always check your values and check your answers. So when you're doing the homework or an exam on equations, you should know before you even enter your answer if it's right or wrong, if you're doing the checks. All right, so again, I just want to go through a few more examples here, some more complicated ones for us to check out. So 3x minus 6 equals x plus 20. And again, I like to draw that little line just so I can see each side of my equation clearly. If I look at each side, there's nothing for me to clean up here, right? I can't do anything. So my first step is done. And again, if you want to leave these steps out for yourself to kind of go through, then leave them out. But our first step is nothing to simplify. So once we've simplified, now we're going to start rearranging things. We're going to start getting those like terms together that are still on opposite sides of the equation. Now, when you have x's on both sides and you have numbers on both sides, you have to choose which way you want to bring everything. Most students like to bring their variables to the left, but you don't have to. So as long as you get your variables on one side and your numbers on the other side, then it will be fine. So I'm going to bring my variables to the left here just to kind of stay in line with most students, but it doesn't matter. So if I want to bring my variables to the left here, I'm going to take this x and I want to pair it over with this 3x because those are like terms. Now there is a 1 here. So the opposite of a positive 1x is a negative 1x or a minus 1x. And that allows me to cancel it on the right and bring it to the left. So 3 minus 1 is 2. I bring down the minus 6 and I bring down the positive 20. Notice I'm staying nice in order and very organized. If my x's are on the left, you want your numbers on the right. So we try to separate into variable terms and constant terms. So this 6 has to come over with the 20. So I have to cancel it on the left and bring it to the right. So if it's a minus 6 here, I'm going to use a plus 6 over here. So if a term is changing sides, we change the sign, right? So if you change sides, you need to change the sign. That's how you move things over the equal sign. So I have 2x left and then 26. Now notice here that all my like terms are combined. So I have my x's on one side, my numbers on the other, and now I'm ready for that third step, which is to divide both sides by the number with the variable. So I need to get the x by itself. That's always my goal. So I'm going to go ahead. Let's get a different color here. How about blue? And we'll divide both sides by 2. And x equals 13 is my solution. All right, I'm going to just do one check here. So I go back to that original equation. I plug in my answer of 13. Now 3 times 13 is going to be 39. And then 39 minus 6 is 33, and 13 plus 20 is also 33. So I do get a true statement there, which tells me my solution is correct. All right, so here is another example. And there we go, my video froze. And again, I'm still gonna put that little line in just for myself to keep me organized. And I look at my left side first and I say, okay, is there anything I can clean up? And there is. I do see a 17 and I see a 3. So I can combine those together, and that gives me 20. And then I have a minus 7x. So just watch your signs. That 7 has to have a negative or a minus sign on it. And on the right side here, I do see a minus 3x and another minus 3x. And again, if you don't like these minus signs, we're going to change them to adding a negative. So negative 3 plus negative 3 is negative 6. And I'm going to bring down that plus 21. So I have cleaned up each side of the equation here. Now at this point, everything is as clean as I can get it. I have to start rearranging. So I do have like terms, but they're not together yet. So I have to rearrange to both sides. So what I'm going to do is I'm going to bring my numbers on the my variables on the left here. So if it's a negative 6x, it's going to become a positive 6x. Now notice here I have a negative 7 plus a positive 6. Minus signs and negatives are the same thing. So negative 7 plus positive 6 is negative 1x. And then I have a 20. And I have a positive 21. Now if my x's are on the left, my numbers are going to go on the right. Positive 20 becomes a negative or a minus 20. So I have negative 1x is equal to 21 minus 20 is positive 1. I do have one last step here. I cannot have a negative there. So I am going to, if it's multiplying, I'm going to divide it out. So notice that my final step is just division. All my like terms are already together. And I have my final answer of negative 1. And again, you can go ahead and plug that back in to check. And I'll let you guys try that at home. So here I have another example. And again, I'm going to start by simplifying whatever I can. On the right side, you're going to see that there is nothing to simplify. But on the left side, I do have that parenthesis, so I am going to use the distributive property and distribute that 5x. So 5 times x is 5x. And 5 times negative or minus 2 is minus 10. Just leaving a little bit more room this time because this one started getting a little bit cramped up here. Now I have to start rearranging. So I'm going to move my x's to one side. I think this time I'll mix it up. I'm going to bring my x's to the right this time. So if I have x's and numbers on both sides, you get to choose whichever way you want it to go. So I'm going to bring my x's on the right. So I'm going to subtract 5x from both sides. If it's positive 5, it becomes a minus or a negative 5. Be careful, that's a negative 10 there. 7 minus 5 is 2. Now I want my numbers together. So if my x is on the right, I'm going to move my number on the left. So minus 14, minus 14. Let's see, I have a negative 24, it's 2x. Again, this is a negative 10 plus a negative 14. And then finally, I want the x by itself. So once all my like terms are combined, I'm going to go ahead and divide. Running out of room here. So I get negative 12 equals x. And again, you can check your final answer by plugging it back into the original problem. All right, I do want to make, I have one more example I want to do, or at least one more example, maybe two that I want to do here first. But I do want to make kind of a note. So let's say you've made a mistake. So I'm going to go back to this part right here. Negative 10 equals 2x plus 14. So let's say at this point you've made a mistake, and what's happening is you want to get your numbers together, but you brought it to the wrong side. So let's say you brought your 10 over here. You decided to do plus 10 plus 10. Now, on the left side, everything's going to cancel out, but you have to have something there. You need something on each side of the equation. So if you've made a mistake and you have nothing left on one side of the equation, then you do need to put a 0 there. And then what you can do is you can correct it in the next step. So you still have to get your variables and numbers separate. So at this point, what you can do is bring that 24 back over, and you will see that you will eventually wind up at the same step again. But I just want to make a note there because this is a very common mistake that students make, is they'll bring everything to one side by accident. So instead of bringing the x's on the right, let's say, and the numbers on the left, they brought everything to the right or everything to the left. And if you do that, you have to recognize that, make sure you put the 0 in and bring something back over. Often students, what they do is they just start doing this and they lose their equal sign and they just make up where the equal sign goes. They'll stop putting it in between the 2x and the 14, which is not correct. So it's really important. That's why I do this line here, and that's why I just write really neatly, is so I stay organized. If you make a small mistake like this, it's not the end of the world. You can fix it. But if you lose your equal sign, or if you rearrange your equal sign, so students will do this as well, they'll put the equal sign wherever they want to, then you're going to be off on your final answer, usually by the sign. So you just want to be really careful there. Let's do another example. So if I draw my line, my right side, I can't do anything, so I'm just going to leave it, but I can definitely distribute here. Now, when you're distributing, make sure you don't go past the parentheses. So once that parentheses hits, I'm going to stop distributing. 3 times 2 is 6, so I have 6x. 3 times 6 is 18, so minus 18. Bring down that plus 6 equals 0. I do have like terms here. So I have a negative 18 and a positive 6. Again, if you don't like those minus signs, just make it adding a negative. And you'll see that negative 18 and positive 6 is negative or minus 12. Now everything is simplified. Notice here I only have x's on the left. So because I don't have everything on both sides, you want to just keep the variable where it is. So if my x is on the left, then the easiest thing to do is to move that other number to the right. So I'm going to use plus 12 on both sides here. And I have 6x equals 12. Notice all my terms are combined. So at this point, you are ready to divide. You don't want to divide too early or usually you'll get the wrong answer. So x is equal to 2. Okay, and our last example here to solve, I want to do 4y plus 80 is equal to 10 times y plus 8. So on the left side, I don't have anything to do. On the right side, I can definitely go ahead and distribute there. So I have 4y plus 80 equals 10y plus 80, right? 10 times 8 is 80. Now, let's start working. So I have my y's and I have my numbers. Both of them are on both sides. So I can choose in this case where I want to bring everything. So I'm going to bring my y's to the left, which tends to be pretty traditional for most students. So I'm going to take that and minus 10y to both sides. So this is 4 minus 10, which is the same thing as 4 plus negative 10. That's going to be negative 6y plus 80. And then on the right here, I also have a positive 80. Now I'm going to go ahead and I'm going to bring that 80 to the other side. So I'm going to subtract 80 here. And on the left side, I get negative 6y still. And on the right side, you're probably saying, but wait, that cancels out as well, right? 80 minus 8 also cancels there. You still need something on the other side. So if you have 80 minus 80, then you would put the 0 in as well. Now, in this case, this 0 is actually fine. I don't actually have an error here because all my like terms are still combined, whereas in the example I gave a few minutes ago with the error, you had everything on one side, like 2 things on one side and only 1 thing on the other. So here I have 1 thing and 1 thing, and this is fine. There's nothing left for me to do. I can't fix this in any way. So you're just going to go ahead and divide by that negative 6. and we get that y is equal to 0. So it is possible to have an answer of just 0, and it does check out, right? If I do 4 times 0 plus 80 equals 10 times 0 plus 8, 4 times 0 is 0. On the other side, 0 plus 8 is 8, and you can see that you do get 80 equals 80. So sometimes 0 is perfectly fine, and it's just a solution. But notice here that when you were at that step, you had one thing equals 0. On the other example that I gave you before, you had 0 and you had two things on the other side. So to get to the dividing step, you need to only have one thing on each side. So that's how we know that here there was an error, whereas this one, 0 just happens to be the answer in this case. All right, so hopefully those are some good examples for you. I could probably do examples all day because they're always of different styles, but you want to just go back to those steps. Let me see if I can find them real quick. And use these for each time. So the big thing in the beginning is look at each side, simplify as much as possible. Second step tends to be the trickiest for a lot of students. So that's why you want to simplify as much as you can so that there's less work to do in part 2. And that's when you're going to start rearranging and moving things around. So you're still getting your like terms together, but they're going over the equal sign. So you have to use that opposite sign there. Step 3 is your dividing. So basically at that point, there should be nothing really left to do but to divide out if there is a number with the variable. And then of course, in part 4, you can check your answers in the original equation.